Hey everyone, this is Mr. Barnett, and this is a walkthrough video for level 2 of the Demographer project on linear models. This is an exciting level for you because you've chosen a population to study, you've learned what a function is, and you've also encountered a challenge, which is given past data about a population, how do you make a prediction about the future? Well, in this video and in this level, you're going to get a tool for making those predictions, and one that will also help us describe what's happened to populations in the past. We have a bunch of learning objectives here, and I'm not going to walk you through each one, but I'm going to give you a general high-level overview of this topic of linear models and then tell you what you can do to build the skills that you're going to need to make a good prediction. Let's go ahead and get started. So let me first talk about this idea called linear growth. What is linear growth? Well, linear growth occurs whenever we see a quantity or an amount grow by the same amount over time. So let me show you an example in a table, right? We have x, our input into the function. This could be years or minutes or hours or whatever. And then y is our output. And if you take a look at y, you'll see that each time x increases by 1, y is increasing by the constant amount of 3, right? X increases by 1, y increases by 3, and so on and so on and so on. For each change in x, y changes by 3. And if we were to put this on a graph, we'll see that this relationship becomes a straight line. Taking a look at the dotted lines on this graph, we see that as x increases by 1, y increases by 3. As x increases by 1, y increases by 3, so on and so on. And when we connect those dots, we'll get a straight line. We can also express our third way of expressing a function. We can express this relationship in an equation. And here's the equation. Y is equal to f of x, and that's equal to 3x plus 1. And if you don't believe me, pause and put some of these x inputs into this 3x plus 1 function machine, and you'll see that we get the y outputs. And so this is a linear model, growth by a constant amount. And it can be declined too, by the way. Two essential components of a line of linear growth. The first is the gradient or slope. And if you think about that word slope, you might think slope of a hill or slope of a mountain. We think about how steep the line is, right? And the steepness of the line is determined by the rate of change. In other words, how fast is y increasing? If y is increasing by 3 or by 2 or by 1 or by 5, that changes the way that the line looks, changes the steepness. And if we think about population, we might think about a population that's increased, having a steep slope, and a population increasing more slowly, having a more gradual slope. We also have a point called the y-intercept, and I'll point to it with my mouse here. It's the point 0, 1. One way to think of that, especially with models, is as a starting point, right? The input is 0. Oftentimes that input is time. So at 0 time, at the start, what is y? What's the output? And so one way to think about this graph is we start at 0, 1, we increase by 3, by a rate of change of 3, and we can decrease by the same amount. So those are essential components of a line. And if we take a look at this equation here, we see it. The rate of change is 3, and the y-intercept is 1. And this is called gradient intercept form of a line. So what will you need to do with lines in order to understand linear models? Well, the first thing we're going to have to do is figure out how do we write the equation of a line. So we had the equation of the line in the past slide, 3x plus 1. But what if we just look at a graph, right? How can we find the equation from a graph? How can we find the equation from 2 points? How could we find the equation from a table? Right? And then we have some special cases in which we'll want to find the equations of lines. So we may want to find parallel lines, perpendicular lines, horizontal lines, or vertical lines. These are special cases, but we need to know them all. How do we write the equations of these lines? So here's an example, right? We have a graph. We have 2 points. From this information, we need to be able to come up with the equation of the line. And then also, we need to be able to come up with lines that are parallel, meaning they never cross, perpendicular, meaning they cross at a 90-degree or right angle, or, compare them with lines that are not parallel or perpendicular. These are kind of special cases for us. Once we can write the equations of a line, we need to analyze lines. So one thing we'll think about is if we have 2 lines, how do we find the intersection of those lines? How do we compare those lines in terms of their slopes or their y-intercepts? And then how do we interpret what those lines mean in a real-world modeling context? So for your population, you have a line. What does that line really mean? Yeah? So here's a couple examples. Here's a situation, a common situation you'll need to do. Take 2 lines, figure out where they intersect, and graphing them is a great way to do this. And another one is to take a real life situation. Here we have cost of renting a car with the miles driven and the total cost. And we need to interpret, what does this line mean, right? What's the initial cost? How much does it cost per mile, et cetera, et cetera, et cetera. So these are the things that we're going to need to do with lines to master this level's learning objectives. One other thing you're going to need to do for the first time in this challenge is use your calculator, your graphing calculator. The calculator is an extremely powerful tool for analyzing lines. And so it's going to save you a lot of time, a lot of energy, and also might prevent you from making mistakes, especially when we're solving for the intersections of lines. So in the organizing document for this level, right, there are some calculator skills videos, and you're going to need to make sure you view them, practice, and understand how to solve, this should say simultaneous equations, how to solve simultaneous equations graphically, and if you have the TI Inspire, how to solve them algebraically as well, okay? This is a powerful tool. Use it wisely. It takes a little while to get the hang of it, but once you get the hang of it, it's going to make you a lot more efficient as a mathematician. Okay, what do you do from here? Well, first I want you to answer some introductory questions about my chosen population. Build your skills, right? You have videos on Edpuzzle. You have practice assignments on Khan Academy. And then once you have built those skills, you can take notes, right? You can record the learning that you have that gets you to the learning objective. You're going to want, once you understand this, to apply it, right? Create a linear model for your population. That should include the gradient and y-intercept. That should include a graph that you create using a website called Desmos, and you'll see instructions for that. And then you'll need to predict your chosen population in 2050. Not just a guess, but actually based on this mathematics, okay? You'll review your work with me, and then you'll complete a self-assessment survey. And at that point, you will be a master of linear models. Good luck, and please let me know how I can help you learn.